Good morning, children. Sairam. Children, in the previous presentation, we have already started with group 17 elements. I have already discussed about the elements which are present in the group 17th of the periodic table, that is the halogen family. Halogen means they are capable of forming salts, so they are called halogens. The elements are fluorine, chlorine, bromine, iodine, and astatine. We have already discussed the occurrence, atomic and ionic radii, ionization enthalpy, electron gain enthalpy, and electronegativity. The physical properties also we have discussed. Now next we are starting with the anomalous behavior of fluorine. Children, as you all know, the elements that are present in the second period of the periodic table, they do not show properties similar to the other elements present in the same group. There are certain properties which they are shown different from the other members of the group. This is due to the small size, as fluorine is smallest in its respective group, so its properties are also quite different. The electronegativity of fluorine is highest among all the elements of the periodic table. It is highly electronegative. The third is the low bond dissociation enthalpy of F single bond F, as the size of fluorine atoms is very small, so there are inter-electronic repulsions, due to which the electron pair which is used in the formation of the bond is repelled by the fluorine atom, due to which the bond dissociation enthalpy is low. And the fourth reason for showing different behavior is the non-availability of vacant d orbital. It do not have a vacant d orbital, so shows properties different from rest of the members of the group. Now children, if we see the order of bond dissociation enthalpy, down the group the length of the bond is increasing. Chlorine-chlorine bond is longer than fluorine-fluorine bond. Bromine-bromine bond is still longer than the two bonds. So down the group the bond dissociation enthalpy should decrease. It is decreasing, it is following the regular trend from chlorine onwards, but for fluorine the bond dissociation enthalpy is low. This is because of the small size and inter-electronic repulsions. Now coming to the chemical properties of these elements. Now you have to remember the common oxidation state shown by all these elements is -1. Fluorine shows only -1 oxidation state because it is the most electronegative element of the periodic table, but the other elements like chlorine, bromine and iodine, they can exhibit the oxidation state of +1, +3, +5 and +7 when they are present with the more electronegative element like oxygen or fluorine. The higher oxidation state of chlorine, bromine and iodine, they are mainly formed when they combine with small highly electronegative element like oxygen and fluorine, like for example in the oxides and the oxoacids. These elements can also show oxidation state of +4 and +6 in oxoacids. Now as you all know, fluorine do not have a vacant d orbital, therefore it cannot expand its octet and shows an oxidation state of only -1. For fluorine only -1. Now all the halogens, they are highly reactive, but the reactivity decreases down the group. Fluorine is the strongest oxidizing agent. The oxidizing power, it is because it can accept the electrons. Most of the reactions of fluorine are exothermic. The reactions are exothermic because and it forms only one oxoacid. One more thing about anomalous behavior you have to remember. HF, that is hydrogen fluoride, is a liquid But if you see hydrogen chloride, HBr, HCl is a gas, HBr also, it is because in hydrogen fluoride there exists a hydrogen bond between the fluorine atom and the hydrogen atom of another hydrogen fluoride molecule. Now, if we see to the anomalous behavior also, again taking in point the anomalous behavior, as I told you, most of the reactions of fluorine, they are exothermic, and this exothermic reactions are because of the small size and strong bond formed by it with the other elements. It forms a strong bond with the other elements. The another example of anomalous behavior was that, as I told you, hydrogen fluoride is a liquid while other hydrogen halides are gases. Now next we are starting with the reactivity towards hydrogen. Now as I told you, when it reacts with hydrogen, when these elements react with hydrogen, they form the compounds of the type HF, HCl, HBr and HI. All these elements, they show affinity for hydrogen, but the affinity decreases from fluorine to iodine. It is because the bond length increases. All the hydrogen halides dissolve in water to form hydrohalic acids. Now, if we see to the acidic strength of the hydrogen halides, then as we know, down the group the bond length is increasing, so bond strength is decreasing. Bond strength is decreasing, that means the tendency to give out a hydrogen increases. Hi can easily give out its hydrogen because the bond is long. So we can say the acidic strength of acids increases down the group. But if we talk about the stability, then stability decreases down the group. So acidic strength increases but stability decreases down the group. Now coming to the reactivity towards oxygen. See children, oxygen, when these elements, they react with oxygen, they form oxides, and most of the oxides are unstable. Fluorine can form only two oxides, but the formula is OF2 and O2F2. But these oxides are not called oxides of fluorine, rather they are called fluorides of oxygen. Out of these two, also OF2 only is thermally stable. Why we are calling them as the fluorides of oxygen? It is because of the high electronegativity of fluorine compared to oxygen. Now both the oxides are strong fluorinating agent. O2F2 oxidizes plutonium to PuF6, and the reaction is used in removing the plutonium as PuXF from the nuclear fuel. Chlorine, bromine and iodine, they also form oxides in which the oxidation states of halogen can vary from +1 to +7. Many different oxides are formed. The order of oxides, the stability of oxides decreases from iodine to bromine. The higher oxides of halogen tend to be more stable compared to the lower ones. Now coming to the reactivity towards the metals, where what happens when these elements, the halogens, react with metals. Children, metal halides are formed, like for example MgCl2, MgBr2 type of metal halides are formed when these elements react with metals. Now you have to remember the metal halides will be ionic in nature, the bond will be ionic in nature, but the ionic character decreases from metal fluoride to metal iodide. If a metal exhibits more than one oxidation state, then the halide in higher oxidation state will be covalent. higher oxidation state will be covalent, and that in the lower oxidation state will have more ionic character. Now, the last one is the reactivity towards other halogens. Children, this topic is very important from the examination point of view also. So, kindly listen carefully. See, when the halogens combine among themselves, one halogen forms a bond with another halogen, then a number of compounds are formed, and these compounds are popularly known as the interhalogen compounds. That means the bond is formed between the halogens. They are of many types like X dash. Here you have to remember that whenever I am calling X, that means it is a larger size halogen, and X dash is a smaller size halogen. This is the general formula X dash. X is the larger size halogen, X dash is the smaller size halogen. The others can be X dash 3, similarly X dash 5, that means in the odd numbers, and X dash 7. Now children, in the board exam, many a times the structures of these interhalogen compounds are asked on the basis of the Vesper's theory. Now see, you all can see when it is X dash 1, the examples can be CLF, BRF, ICL, IBR and other such. Now their shape, structure we cannot say because it will be a two-dimensional structure, but these ones are important, these and these. Now first of all, let us discuss the case of X dash 3. See, I am taking one example. The shape of all these examples, the structures of all these examples will be the same if the general formula is same. Suppose I am taking CLF3. CLF3. Now chlorine, the atomic number is 17. The configuration will be 1s2, 2s2, 2p6, 3s2, 3p5. 3p5. So the outermost shell configuration is 3s2, 3p5. That means in the s orbital 2 electrons are there, and in the p orbital 5 electrons are there. 1, 2, 3, 4 and 5. Now see here, chlorine has to form 3 bonds. So 3 unpaired electrons are required. This electron will shift to the higher d orbital. Now see, after this 2 lone pairs are left and 3 bond pairs are left. Now when 2 lone pairs and 3 bond pairs, that means a total of 5 bonds are there, then the geometry should be trigonal bipyramidal. Trigonal bipyramidal. Now in trigonal bipyramidal, the chlorine atom will be present at the center. Now 3 fluorines will be arranged in such a manner that they are quite close to each other, but the 2 lone pairs should be arranged in such a manner that they are maximum far apart from each other. So it is like this. The 3 bonds are on the same plane, this lone pair and this bond are on the same plane. 1 bond above the plane, 1 bond below the plane, but the bond which are present above and below the plane are tilted a little bit towards the other fluorine side. It is because the lone pairs are repelling the 2. So this geometry is called bent T-shape geometry. It is bent T-shape. See, The geometry is called the bent T shape, and whenever the general formula is of the type XX-3, the geometry will always be bent T shape for all these four compounds. Now see, the next type of your interhalogen compound is XX-5. Now see, when the general formula is XX-5, all the compounds will have the same geometry, that is all three of them. Now let us discuss the case of Cl12. Now for Cl12, the geometry will be Cl12. This is Cl12. When Cl12 is there, then one lone pair and how many bond pairs will be there? 5 bond pairs will be there. One lone pair and 5 bond pairs. Now, Cl will be present in the center. 4 fluorine atoms will be present on the same plane forming a square. One lone pair will be either above the plane or below the plane. I am showing this below the plane, and one bond pair above the plane. So the geometry is square pyramidal. This is square pyramidal. Children, you have to know how to draw the geometry. It comes in the board exams many a times. So all those compounds which are having the general formula XX-5, the geometry will be square pyramidal. The next type of interhalogen compounds are XX-7. For XX-7, you draw the geometry yourself. It is pentagonal bipyramidal. See how it will be? It will be the, just a minute, IF7 example I'll show. I will be present at the center. A pentagon will be there and a pyramid. So the geometry will be like this: pentagon, bipyramidal. One above the plane, one below the plane. Now children, about these interhalogen compounds, one question that is generally asked is, in general, interhalogen compounds are more reactive than the pure halogens except for fluorine. Why is it so? We can say that interhalogen compounds are more reactive than halogens. Why? This is because in case of interhalogen compounds, this bond is weaker compared to XX. Like if we are talking about CLF, then the bond between Cl and F will be weaker compared to the bond between Cl and Cl. So it is easier to break the bond. So these interhalogen compounds are more reactive. Okay, this was all about the interhalogen compounds. Now next is chlorine. We have to study the preparation, properties and uses of chlorine. See children, chlorine, as you all know, the best method is by the electrolysis of sodium chloride. Electrolysis of sodium chloride, brine solution gives out chlorine gas. Another method is by heating manganese dioxide with hydrogen chloride, will also give chlorine. And the third method is by the action of potassium permanganate on hydrogen chloride, will also give chlorine. This preparation is generally not asked. Next is the properties. You have to remember, it is a greenish yellow colored gas. It has pungent smell and suffocating odor. When it reacts with metals, it forms chlorides of the type NaCl, AlCl3, FeCl3, PCl3, etc. It has great affinity for hydrogen. Now, when it reacts with excess of ammonia, this is important, children. Many a times it is asked in the form of reactions. When it is reacted with excess of ammonia, when the ammonia is present in excess, ammonium chloride is formed and gives out nitrogen. But when chlorine is present in excess, it gives nitrogen trichloride, which is a explosive. So you have to remember the difference between the two. What happens when ammonia is present in excess and what happens when chlorine is present in excess. Now next is with cold and dilute alkali, it reacts in another manner and produces chloride and hypochlorite. But when it reacts with hot and concentrated alkali, it gives chloride and chlorates. These two are very important points you have to remember. Now you all know chlorine is a very important component of bleaching powder also. The bleaching property of the bleaching property of bleaching powder is due to the presence of chlorine. With slaked lime, when it reacts, it gives out bleaching powder. Now, when it reacts with any hydrocarbon, a substitution reaction is formed and the products like CH3Cl are formed. Generally, the substitution takes place in presence of sunlight. Now, this chlorine is a very good oxidizing agent, or you can say the bleaching agent. Bleaching means to decolorize something. Now, uses of chlorine are important. It is used in the bleaching of wood pulp for cotton and textile. Now this wood pulp is used in the making of paper and rayon. It is used in extraction of platinum and in the production of compounds like CCl4, CHCl3 and DDT. It is also used in sterilizing drinking water. We add the chlorine tablets. Now the question that generally comes from uses in the board exam is name two poisonous gases which are prepared from chlorine. So you have to remember these are phosgene and tear gas. Mustard gas is also there. The formulas are written here. Kindly learn these formulas. It comes in the board exam. Name two poisonous gases which are prepared from chlorine. So they are mustard gas, tear gas and phosgene. Now next I am starting with hydrogen chloride. Now the preparation, how HCl is prepared. There are two methods of preparation of HCl. First is the reaction with sodium chloride with sulfuric acid. Second is sodium hydrogen sulfate with this sodium chloride. Both will give you HCl. How HCl is, the properties we are studying now. It is a colorless, pungent smelling gas. You have to remember HCl is not a liquid. Its aqueous solution is called the hydrogen chloride, hydrochloric acid, but actually HCl is a gas. It is extremely soluble in water and its aqueous solution is called hydrochloric acid. HCl is a gas. Its aqueous solution is hydrochloric acid. It decomposes the salts of weak acids and gives out water and carbon dioxide. Now coming to the uses, it is used in the manufacture of chlorine and ammonium chloride and glucose. Now it is used in medicines also as a laboratory reagent and many times as a solvent also. Now the last topic of the group 17th element is the OXOACIDS of halogen. Children, generally the structures of halogens OXOACIDS are not asked in the exam. Sulfur ke OXOACIDS, they are asked in the exam. But you have to remember, you should have a general idea about the OXOACIDs. Only structures are there in the syllabus. The question that is generally asked, I will tell you later on. First of all, you see, fluorine is forming only one oxoacid, that is HOF, and chlorine, it forms 4 oxoacids. The structures you all can see. Bromine is forming 3 oxoacid, iodine is also forming 3 oxoacid. The question that is asked in the board exams generally for these from the topic oxoacid of halogen is fluorine forms only one oxoacid. Fluorine forms only one oxoacid, whereas the other halogen forms several oxoacids. Why? So the answer for this question is due to high electronegativity and very small size. It can form only one oxoacid, that is fluoric first acid, that is HOF. It is also called hypofluorous acid. So the main question that is asked from this topic is why fluorine forms only one oxoacid. You have to remember it is also one of the property related to the anomalous behavior, that is small size and high electronegativity. Now children, certain questions, the in-text questions are there. I am discussing those in-text questions orally here, and you have to see, you have to write down the answers for all the in-text questions in your fair notebook. It is very important from examination point of view. In-text questions are asked. Now see, like for example, if you go to page number 193 of your NCERT book, there is an in-text question given. Halogens have maximum negative electron gain enthalpy in their respective periods. Yes, halogens have maximum negative electron gain enthalpy in their respective periods. Why? So you have to remember, because they have only one electron less than the stable configuration. So they readily accept that one electron and give out a lot of energy. So that is why they have maximum negative electron gain enthalpy. Another question is, although the electron gain enthalpy of fluorine is less negative compared to chlorine, yet fluorine is a strong oxidizing agent. Why? So the reason is due to high hydration enthalpy. In board exam, many times this question is asked that though the fluorine is having less negative electron gain enthalpy compared to chlorine, yet it is strong oxidizing agent. You have to remember the answer is due to high hydration enthalpy. Another question is, fluorine exhibit only -1 oxidation state. Fluorine exhibit only -1 oxidation state, while the other halogens can exhibit +1, +3, +5, +7 oxidation state. Why? So why it happens? Because of the absence of vacant d orbital. It is the most electronegative element and cannot exhibit plus oxidation state and cannot exhibit -2, -3 also, because of the absence of vacant d orbital. Now another question is, give two examples to show anomalous behavior of fluorine. For anomalous behavior, many examples are there, like the same question that the previous question, fluorine can exhibit only -1 oxidation state. This is also one of the anomalous behavior. Another anomalous behavior is in the trend of your bond dissociation enthalpy of FFCl. Here FF is having lower bond dissociation, lower bond dissociation enthalpy compared to Cl. This is an example of anomalous behavior. Now children, another question, the in-text question is, you have to write a balanced chemical equation for the reaction of chlorine with hot and concentrated NaOH. For hot and concentrated NaOH, I have told you, when it reacts with metals, yes, for hot and concentrated NaOH, when it reacts, it will form NaCl, NaClO3 and H2O. Now another question is, give reason for the bleaching action of chlorine. Bleaching action of chlorine, as I told you, is just because of the oxidizing power. Yes. Name two poisonous gases that can be prepared from chlorine. They are phosgene, tear gas and mustard gas. Do remember the formulas also. So children, I'll wind up for today. In the next presentation, we'll start with the group 18th elements of the periodic table. Till then, note down all the in-text questions also in your fair notebook and download the PDF for the NCERT this exercise solution. Do write all the questions in your fair notebook. Everything in this chapter will come from NCERT only, nothing from the side books. Do study from the NCERT book only. Thank you. Sai Ram.